we'll keep moving on. My name is Charlie. I'm a home inspector in Chicago, and I just like to share a little bit of knowledge on different items in the home inspection business that I can. So today I'm going to talk about asphalt and fiberglass shingles. And if somebody does have any questions, please feel free to type those questions in. It looks like we can see the video now, and everything seems to be working just fine. So the first thing is I like to talk about some definitions. The first definition is called a square. And if this is basic and you know this stuff already, please bear with me. I know there's always going to be one or two people that doesn't know this, and I'd rather share as much as I can for those that don't. So the term square, it means 100 square feet. It doesn't necessarily have to be a 10 by 10 area or 25 by 4 or 20 by 5. None of that has to be in play. It just has to total up to 100 square feet. What we're looking at here in this picture is a gentleman who's drawing circles around pockmarks or hail damage on the roof. Different insurance carriers have different numbers of what's acceptable and what is not acceptable. They all go by a square, so how many marks they're going to have inside of a 10 by 10 or like I said, 100 square foot area. They're going to, whatever that number is. Some of them are as low as 5, some of them are as high as 15. All right. And we're not going to know who the insurance carrier is or how much it is. But we should start, looking and seeing if we could recognize some obvious pockmarks that comes on there. All right. The next question we get is always going to be, how long is this roof going to last? What's the lifespan of this roof? And that's another thing that's just not easy to tell. All right. They make shingles that range anywhere from 15-year lifespans all the way up to 50-year lifespans. Now, there are a couple of shingle gauges. This one we're looking at here, I believe, is for organic. I'm pretty sure this one's for organic shingles. And they have another one that's a little bit longer that's for fiberglass shingles. And you'll see that the thicker the shingles, that doesn't slide in as far, and that's how they determine what the lifespan is. Now, none of this is inside of our standards of practice, so we don't necessarily have to do this. I am a big believer in doing as much as you can and providing as much information as possible. But again, it's not something that absolutely has to be done. Knowing how a shingle is put together kind of helps you diagnose what's happening with the roof when you start seeing different things going up and down. The first thing that we're going to have is an organic felt paper, and that's going to be the meat of the actual shingle. What they're going to end up doing then is putting an asphalt coating on the top and the bottom of that layer, and the thicker that asphalt coating is, also the thicker the mat is, the longer the lifespan is going to be. But asphalt does have one weakness. It's a pretty big weakness that it has, and it's going to be the sunlight. So when we're dealing with the sunlight, we actually have to protect the sun from getting to the asphalt layers. And that's when you see those granules that are put on top of those. So this sheet right here, this is for a fiberglass shingles. And this is a fiberglass mat where they're going to start off putting everything together. Now they're going to put the asphalt on top of this and underneath of it. We kind of zoom in a little bit. You can see it's just a lot of, fiberglass mesh. You can almost see through it. So it's not one solid piece that comes in there. They want to maintain pliability and make sure that it could still bend and be movable. And even a closer view here. Now, there's no asphalt, obviously, on these things. And if you ever see a shingle that's been damaged and it has some pocks in it, or some of the granules have pulled away, you'll actually see some of these white lines that's inside the asphalt when it's mixed together. Typically, this is what we're going to end up seeing as our final product, are these 3-tab shingles that comes on here. When these things are put together, that felt paper is, it goes through the factory, and I want to say they're like 6 to 8 or 9 feet wide. Then they go ahead and they sandwich on the asphalt on the top of the bottom. Then they put the granules on top to go ahead and protect it from the UV rays. Then they come back and run it through a machine that's actually going to cut and make all of our tabs here as we come across. Now, realize that when we cut these tabs, we don't have any granules that are touching the sides here when we put forward. What happens if I had the sun that was coming down on this way here, that's going to hit this side of these rain tabs, and that actually starts to cause that to shrink. When asphalt dries out, and it dries out from the UV rays of the sun, that's when it ends up shrinking as it gets smaller and drier. We're going to see those tabs on the three tab shingles. We're going to see those things opening up. What makes it a little bit harder is when we get to these architectural shingles. All right. Typically, these are going to be two different layers when they put these things together. Sometimes it's more. If we look at the underside, we can actually see the two different layers that are on here. And we can pull those apart if we go ahead and turn it sideways. All right. Now, one of the things about architectural shingles is when they're installed, they look great. There's no ifs, ands, buts about it. You can install these things in the absolute worst way possible, and they're still going to look good. And that's why it's hard, especially from the ground, to go ahead and inspect these things. With the 3-tab shingles, and this is different in different parts of the country, but here in the Chicago area, we do what we call a 50% offset. And right about, oops, I hit that with my finger, but right about there, there's going to be a slot or a slit right there. There's another one there, and then there's another one here. So that when I put the second shingle on, we're going to be able to line these up so my rain tabs are 50% offset, and that way they're not going to line up with each other. I was out in the Kansas City area one time, and I was looking at a roof as I'm driving by, and it just looked really weird for me. They ended up putting their rain tabs on a 33% offset. So when you go up and you're looking up the roof, instead of every other one going up there, it looks like the rain tabs are actually going up on an angle. And of course, anything that you're not used to, you're going to think it's weird, but that's actually the norm there. So it didn't, that's actually the norm there. So it wasn't actually a problem when it was installed. All right. With the the dimensional shingles or architectural shingles, we're not going to have that luxury. And they come in all different patterns when we're dealing with these shingles. So sometimes they look like slates, and I've seen them where they have the patterns in them where they actually look like clay tiles. All right, until you get up closer, it's hard to tell what material they are. Now, putting the asphalt shingles down, there are a couple rules. We do want to put down felt paper. Felt paper does two things. One is it does give us another water penetration barrier, all right? It's not a very good one when we're dealing with the felt paper, and I'm talking about this side over here on the right. It doesn't do that good of a job because it doesn't self-seal. We're throwing a whole bunch of staples and nails in here. I really don't think that it does that much of a protector when it comes to it. I treat this more as a lubricant for the asphalt shingles. When we have a wooden deck, that wooden deck is going to expand and contract at a different rate that the shingles are going to be expanding and contracting to. And we kind of want to put a little bit of a breaker bond type material on there to go ahead and keep it free so it doesn't adhere to the actual deck itself. We want it to keep that separation. Now the first row coming across, the first row here is going to be ice and water shield. Now, different manufacturers come up with different names, but I like to just call it ice and water shield. This is a self-adhering, self-sealing membrane that we actually unroll it, peel it off, and it sticks right to the base of everything. When we're dealing with wood shakes, clay tiles, slates, we need to have a certain amount of ice and water shield. And if you're taking any sort of test for the National Home Inspector exam, you should really know this. So if we have our roof here, and let's say that this is my interior wall, so that's our overhang, the minimum that you could have is 3 feet, and that's going to be as an angle. But it does need, the ice and water shield should go to the interior at least 2 feet. So wherever that wall is, we could draw a line up on that one and a line up on this one. So sometimes we might actually need 2 rows of ice and water shield so that we can get to this point where we're 2 feet to the interior. Everything happens with whatever size or the slope of the roof is, and where the walls are and how big of an overhang there is. All right, so not always is 3 feet going to cut the mustard. Sometimes we're going to have to put a second layer on there. And that helps, especially if you got a house that has poor ventilation, poor insulation, and a lot of bypasses, and we're letting a lot of heat get up into the attic. We're going to start melting that snow that's up on the roof, and that's going to come to the overhangs. I'll draw my house back up there again, even though it's crooked walls here. So if I have heat loss coming up here, my snow is going to turn to water, and that water is going to be a liquid. Once I get back to this overhang, this is actually going to start freezing. And then that water is going to keep melting. It's going to keep going over the top of it. And this is what we call an ice dam. All right, we're going to have water right there. And usually it's followed with a whole bunch of icicles that are coming down off the side. I know my drawings aren't the greatest in the world, so I'm sorry, but as long as they're getting the point across, that's all that matters. Couple other rules when we're dealing with ice and water shield. When we're at the eaves, and we can see over here on the left-hand side, we have gutter apron flashing there. We want to put our ice and water shield on top of the gutter flashing. In our area, it's a common practice to put the eave flashing, which looks a lot like gutter flashing, but it isn't. We put our our rake flashing on top of the ice and water shield. So at the eave, the ice and water shield goes on top of the flashing. At the rake, the ice and water shield goes underneath. Now what they're doing here in this middle picture is pretty much the best practice. This is called a starter roll, or starter roll that we see in here. So that's one long piece that goes all the way across the roof, and that's what we need to basically double up. This isn't common in our area here. Typically what they're going to do is take that first shingle and they're going to spin it upside down, and usually they're going to go with the cheap 3-tab shingle, and then they're going to put what would normally be the top side of the shingle, they would put that bottom one here, and then I would just end up seeing like this, a 3-tab shingle coming all the way down underneath there. Then we'll go ahead and put our first row right on top of that, just like what we're seeing in these pictures. So now on the left, we can see we're starting our first row. They're going ahead with our second row up in here. This black darkened area here, that's what they call the self-sealing strips. Now they started installing those self-sealing strips on shingles, I want to say somewhere around 1960s, early, middle, late, whatever it is. And then we've been doing that ever since. Usually you're going to have to hit temperatures in the 80s, 90s in order for that to start getting liquid-like, I guess, or tacky-like. And that's when they're going to start adhering to the shingles above. If we didn't have this, then every time the wind would blow, our shingles would just want to lift right up, and then they'd start bending and cracking, and then we'd end up losing all of our shingles. On the right hand side of this slide, you can actually see how they're stepping up. It looks like they're doing one of those 50% offsets as they're going up. But again, you're just not going to be able to tell. So down here, ice and water shield. After our ice and water shield, we put in our felt paper, and then they just keep working their way up the line, and then they'll come back here and do another row, and then another row, and another row, until they get everything installed. As I was saying earlier, the shingles come in many different shapes, colors, designs. You know, don't be alarmed by it. One's not better than the other. It all depends on how thick they are and what their lifespan is. And unless you have one of those gauges, or you have one of those, or you actually have a wrapping from the bundles, you're actually not going to really be able to tell how thick they are and how long they're going to last. And I'm sure that there's somebody listening to this that, you know, says, oh, I could pick this out, and they have far more experience than I do. And if that's the case, God bless them. You know, I'm sure there's a talent for everything. I definitely don't have it. All right. So some of the problems that we run into with asphalt shingles are going to be weather issues. The biggest enemy that I want you to remember for shingles is always going to be the sunlight. And the only protection we have for the sunlight are going to be those granules. Let me go back here. The granules that we're showing that are basically giving its color and design and its attractiveness, all right? Its main purpose, though, is to protect the asphalt from the UV rays of the sun. Heavy water flowing into an area, that can wash off those granules. And you're going to see that everything that we mention on these problematic areas, they're all going to come right back to losing the granules. Once we lose the granules, then we lose the roof, plain and simple. So heavy water going in one area, you'll see some home inspectors will talk about large roof discharges and gutters and where they're flowing over shingles and they could wash away some of the granules. I don't really make a big deal out of that. I haven't seen a roof yet where we had that much water come by in one specific area that shortened the lifespan of that roof up by so much that I had to end up replacing the entire roof. All right. And so, I mean, I'll concede that it does wear that area out faster. But the question is, are we talking about 50 years versus 49 years? Are we talking about 20 years versus 19 years and 6 months? You know, I just don't think it's that much of a big deal. And again, everything goes back to opinions, and we're all entitled to them. So wind can always blow up the shingles and cause them to be damaged. Trees coming down, which is going into the impact damage. Hail damage is another thing that comes on there. Debris on a roof over time, that's just going to start holding water and getting algae growth. And once that starts happening, then that's going to start deteriorating our shingles. Poor installation, we'll show some pictures there. Rarely are you going to run into material failures, but that happens as well. You're going to find that sometimes water will be in between the layers. And when that happens and it turns to steam, that's going to lift up the granules and cause those to flake off. Cracking, premature craze cracking is another thing. And then ventilations. When we start letting these attics overheat, then that's going to cause the bottoms typically of the shingles to start to expand. And you're going to end up seeing a lot of curling. And then eventually it's going to start clawing. And for those of you who don't know the difference between that, if I have a shingle here and it's coming up on the corners, and that's curling, all right? And then if they're going down, you know, and I think it's kind of like a bear claw or whatever. So yeah, if they end up turning downwards on the shingles, this is called clawing. Oops, sorry. When we get to the clawing stage of a roof, we're done. And the sad thing is, if we're curling or clawing too much on these, we can't even replace or put a second layer of roofing on. Now, most of the United States, they do allow you up to 2 layers. I know that's in the IRC. But for those in the southern parts of the United States, I don't think that's a common practice for you guys. All right. If somebody knows better that you're only allowed to put 1 layer on down there, please type it into the comments. And I'm pretty sure that's the case, although I know that the IRC does say you could go up to 2 layers. All right. So sunlight I mentioned already, that's going to be our #1 enemy. Making sure that we don't have any damage to the granules and everything's in good shape is going to have our roofing lasting the longest. Anytime I see anyone go up there with any sort of tar at all, then unless that tar is protected from the sunlight, you're in our area, we usually get about 2 years. And I bet you in the southern climates, you guys are going to only get about 1. With this picture here, they're showing erosion, and they're trying to show that all of the granules were washed off on this area. Now, if we get something that's this bad where I don't have any granules left and it's nothing but asphalt that's on there, obviously this is bad. But I just found this as a picture in the InterNACHI classes. I never ran into anything with my own eyes with stuff like this, or at least not in an isolated place because of water movement. Here we're showing the ridge of a roof, and I think these shingles were relatively new. And again, the wind just hit them hard, and it started blowing them off. So we're missing some of the shingles, and then they started cracking off. The darkness that you see on that, that's going to be the part that was supposed to be overlapped or hidden, and because it's not the finished colored shingles or finished colored granules that we're seeing. Hail damage is kind of a big deal. We actually made relationships with insurance adjusters in our area. And I know a lot of people criticize them. They call them storm chasers and such. And, and I'm sure there's good and bad humans in every field, including ours, all right? But it happens, and the insurance companies are going to pay for somebody to get a new roof. All you need to do is know the rules and how to file for it. And a lot of people don't know this, but when you're doing an inspection, you still have to get permission from the sellers. But if I'm doing an inspection for the buyers and I start seeing hail damage on there, I can inform my client of that, and they could actually file a claim on the seller's insurance. Now, the check is going to go to them, but as long as they get the attorneys and they make an agreement over everything, why not? If I'm looking at a roof that needs to be replaced and we're looking at a $16,000, $20,000+ bill, and now we could go ahead and make an insurance claim out of it because we recognized something was insurable. Well, we just went ahead and I know we're not in the business of selling houses. I get it. But if you can make a problem go away, that's not a bad thing. All right. Our job isn't only problem finding, it's also problem solving when it comes to it. So with these things, we got these dark spots in here, and these are the hail damages that they're talking about. And again, depending on how many in a square that they find, each insurance carrier is going to be different, whether or not they'll go ahead and pay out on that claim or not. All right. But it's all legitimate. All you got to do is know how to work the system. All right. Here we just had storm and a tree branch came down and damaged some of the shingles. This is kind of a no-brainer. You go up there, we take our picture, and then we can move along. The good thing about asphalt shingles, it may not look the prettiest thing in the world, but you can always replace just some of these shingles. In fact, you could do that on just about every roof. You don't necessarily have to replace the entire roof, but I always leave that decision up to my client, and I don't go further from there. Now, we got a couple rules, about walking roofs. We try to stay off the roof when it's over 85 degrees. Definitely not over 90 degrees. Just by getting up there, and if you drag your foot or twist your foot on the shingles themselves, it's already so soft from the heat. The asphalt is so soft from the heat that you'll just tear those granules right off on it. And once you did that, you expose that shingle, you expose the asphalt of the shingle, and then once the sun hits that, we're going to start shortening our lifespan again. All right. This picture I just thought was cool. Very rarely are you ever going to run into something that's this severe. But we take pictures of any algae growing on a roof, even if it's on the very early stages, and you'll see the dark stains on the roof. And sometimes, like where the plumbing stack is or roof vents, you're going to, so for example, if I had a roof vent here, and I had a plumbing stack there, sometimes you're going to see everything is dark in color, and then you're going to have areas right underneath here where it looks like it's all brand new and nice and clean. A lot of that happens with the zinc that's in the metals, and it causes the algae to die. It just doesn't let it grow. In fact, they actually sell zinc strips that you could slide up underneath the shingles. Now again, things are different in different parts of the country. We don't get hit hard when we're dealing with algae and growth in this area here. I was talking to a couple gentlemen that I greatly respect. One, his name is Dylan Chalk, and I know he works with the Scribeware software that's on there. He lives in Washington State, and he made a comment as a joke that I thought was pretty funny and really interesting. And that was that anything that stops moving for 5 minutes, algae is going to grow on it. So in Washington State, where he's at, I'm sure it's very common to get roofs where the algae is growing pretty thick like this. I don't think this is a smart idea. I think once it gets into this area, it's going to want to work its way underneath. It's going to start delivering water and moisture to the substrate underneath. I definitely would not ignore it, and I would get up there with whatever chemicals I can to go ahead and get it off. I wouldn't power wash it, because then obviously we're going to be damaging the roof, or at least the granules of the roof. So I wouldn't want to go ahead and do that either. This was just poor shingle. Somebody went ahead and did a repair, and they just grabbed a bunch of different shingles and slid them up there. It's probably going to work. The whole goal of a roof is to keep the water from coming into the house, plain and simple. And if they did have some sort of damage right there, and this is what the repair was, and it's not letting water come back in there, I guess it wouldn't be too much of a problem. But I can't ignore stuff like this. Anytime I see something that looks unusual or awkward, we have to photograph it. We have to put in the report. We got a couple of rules or whatever in our company, and one of them is don't let somebody else's problem become your problem. All right. If our clients are paying us to educate them and give them knowledge about the roof, and they may not have looked up or really looked at it closely or seen it from a different angle because maybe a tree was blocking the view, who knows? And maybe they did see it and they're dishonest, who knows? But we just don't want to take that risk. We're going to document it. You can always give your opinion. If you think this is terribly bad, then all you have to do is say the shingles are not installed as they normally would be or to the manufacturer's specs. And in my opinion, I think this is minor. In my opinion, I think this is major. I think that the entire roof should need to be redone. Whatever your opinion is, your opinion is. And a lot of people don't realize this, but your opinion can never be wrong. Our clients are paying us for our opinions, and just give it simple and humbleness. That's it. So it is installed wrong. There's no ifs, ands, buts about it. But just from what I'm seeing here, I don't think that it's going to be a problem. Now, that doesn't mean that I'm stopping here. I'm going to get my butt up into that attic, and I'm going to get on the underside of this thing, and I want to see how much water damage was done before. I'm going to make sure I have a moisture meter on it, especially if it's rained in the last few days. And I want to make sure that there's no water coming up on the inside, or at least give me some sort of clues that either it is a problem or it isn't a problem. And that way I could be a little bit more definitive. The slope of the roof is kind of important. Um, yeah, the same guy. These guys out in Washington, I told you I like them a lot. And Charles Buell has this diagram up there where they talk about shingles not supposed to be installed on less than 3.5 in 12 slope when it comes to it. And all that, when you get down to that low of a slope and you get the overlapping of the shingles, they were showing that you can actually hold water onto the shingles just like if it was a flat roof. Now that's something we never want to do. Whole idea of a shingled roof, or even with wood shakes, wood shingles, slates, tiles, all those sloped roofs are designed to shed water and drain water. If we're not allowing that water to shed or drain off the roof, that will be a problem for that roof. Plain and simple. This is another common problem that we run into in our area. The nails, they're not pushed in all the way, or sometimes over time when you get a hot attic, things start expanding and contracting when we're dealing with the plywood, or if they don't leave gaps in between the plywood, then that when the plywood expands, it's going to kind of buckle, all right? And when it buckles, it lifts up on the nails. And then wintertime comes back again and everything settles back down, but the nails are still sticking up. Then the shingles get hot and the nails start punching their way through these things. Obviously, that's going to be a clear opening straight to the inside, and something like this is going to be easily going to cause a leak, all right? The repair on these things, I think, is relatively simple. You know, you could either replace the damaged shingles, that is an option. But I've seen people where they'll go ahead and lift up this shingle, and then they'll slide a baby tin underneath here, put a little tarring above and below it, and then that ends up sealing it fairly well. So if you have a client that's looking for an inexpensive way to fix this, that is an inexpensive way to fix it. If your client wants to have the whole roof and try to negotiate for it, that's their choice. All right. I try to give them the different options and let them choose and go ahead and do whatever they want to do. On these drawings or these pictures here, we could see the cracking, and I'll just draw right above this cracking here, and then right over in there. And when stuff like that happens, and the shingles are relatively new, and we could tell these are somewhat in the newer stage just because of the gap in the rain tab in there. Remember what I said before, when the sun hits it on an angle, then these rain tabs, they start opening up like this. And the wider they get, the further along it is in their lifespan. Typically when a shingle is brand new, it's going to be about 1/8 of an inch to 1/4 of an inch gap. And then it doubles every quarter of its lifespan that it goes through. Right? But these cracks here are a manufacturer's defect. The manufacturers, at least all the ones that I'm aware of, there might be some that I'm not aware of, they'll pay for the shingles to go ahead and get replaced, but they don't always pay for the labor to go ahead and take the old shingles off and put the new ones on. So that would be something you want to bring up to your client. Here we're showing shingles where they're actually clawing. And think of like a bear claw. You can see how the edges are going down on that. These shingles are well beyond their expected lifespan. I don't care if they're leaking or not. I want my client to be prepared that not only is this going to be a new roof, but we're also going to have to tear off the old shingles. Right? We can't just put a second layer on top of this one. And the reason is because we need those shingles to lay flat. And just because it's all curled and lifted up like this, it won't let the next layer lay flat. And then it's going to shorten the lifespan and you're just wasting your money. You're better off tearing it off and then move along from there. Here they're showing it as a ventilation problem, but it could also, and it's probably because these shingles really don't look all that old. And once you start getting super heated up like that, you'll get curling and clawing. That's actually a common practice. All right. Well, this is a shorter one, as I mentioned. I didn't have any of my helpers with me, and I should have reached out with them a little bit more to get there. But if you do have any questions, I'm going to go and look at the message board right now. I'm kind of blinded from it, so I couldn't see it, but I do see a few people put a few notes up on there. If you got any questions, just type them in there, and I hope this stuff helps. And that's all I got. Thank you, everyone, for listening.